The hot wind from galaxy M82 measured at over 3 million kilometers per hour.
Astronomers have managed to directly measure the speed of a wind of superheated gas emanating from the center of the M82 galaxy, a neighboring galaxy known for its intense star formation.
This hot gas moves at over 3 million kilometers per hour, about 2 million miles per hour. Scientists believe it is the main force driving a cooler, larger wind that extends up to 40,000 light-years from the galaxy's core. The measurement was made thanks to the XRISM space telescope, a collaboration between the Japanese space agency JAXA and NASA. The Resolve instrument aboard the spacecraft analyzed with great precision the X-rays emitted by the superheated iron at the galaxy's center. The gas is at an impressive temperature of about 25 million degrees Celsius. This high temperature creates enough pressure to push the material outward, similar to what happens when pressure differences generate winds in Earth's atmosphere. The speed was calculated by observing the broadening of the spectral lines of iron, caused by the Doppler effect, the same phenomenon that makes the sound of a siren change pitch when the vehicle approaches or moves away from us. In the case of M82, the gas moves rapidly in opposite directions, which broadened these lines and revealed even greater speeds than some models predicted. M82, also called the Cigar Galaxy, is located 12 million light-years away in the constellation Ursa Major. It forms stars about 10 times faster than the Milky Way, which is why it is classified as a starburst galaxy. Telescopes such as Chandra, Hubble, Spitzer, and James Webb had already shown the cold, extensive wind that expels gas and dust from this galaxy.
Now, XRISM has looked closely at the central cauldron, where shock waves from newborn stars and supernovae heat the gas and initiate the outward flow. Astrophysicist Aaron Burcher, from the University of Maryland and NASA's Goddard Space Flight Center, explained, the classic model for galaxies like M82 says that shock waves heat the gas and start a powerful wind. Before XRISM, we couldn't measure the speeds needed to test this idea. Now we see that the gas moves even faster than some models suggested, enough to push the wind to the edges of the galaxy. The results show that the hot central wind can explain much of the larger, cooler wind observed. This may reduce the need to use cosmic rays as the main explanation. Although they may still play a role, however, there are still open questions. The center of M82 ejects gas equivalent to forming about 7 sun-sized stars per year, but the measured wind appears to remove only about 4 solar masses of gas per year. Researchers wonder where the rest of the material goes. These observations help to test and improve older models of starburst galaxies, created since the 1980s, and provide new clues about how the energy of supernovae and star formation influences the evolution of galaxies. The study was published in the journal Nature.